our research center is called the CARLAB, Continuous Auditing and Reporting Laboratory, because that's kind of the work that I did at Bell Labs 40 years ago, something years ago. And I'm going to talk to you a little bit about that and then link to some other things. I have been reading a couple of books on current AI. And I want to discuss a little bit some of the things I'm trying to learn there. I am going to try to find a video for you to see. I think this, I liked your responses, your analysis, the ones I got for video. So I think I might adopt that method. Getting everyone to read something is more difficult than getting people to listen to a video. So I might try something a little bit different. Okay, so the story here, I got to Bell Labs and I was a friend of the CFO. The CFO was a retired, was not a retired, was an ex-partner of Cooper's and Lybrand. You know what Cooper's and Lybrand is? Cooper Lybrand was one of the big 8 that became big 4. And Cooper's and Lybrand, PW, PricewaterhouseCoopers. So they merged into Pricewaterhouse. And Bob Kavner was, when I joined USC, they asked me to teach IT audit. And I have never even taken audit, imagine IT audit. So what I did is I invited the IT heads of IT audit in each one of the big 8 to come and talk to my class. And Kavner came, and he was really more like a generic auditor, but we became friends. And when I moved to New York, he had left Cooper's and became CFO of AT&T at that time, just post-divestiture. Remember, AT&T had 1.2 million employees, then the government said this couldn't be a monopoly anymore, so they split out 7 operating companies and kept the long-distance business. And, 10 years later, they had 30,000 employees. At the split up, they had like 350,000. And so Bob joined there and was the CFO. And when he realized that I was at the labs, had left Columbia to the labs, he said, go and talk to the internal audit guys. They might need some help. So I went to talk to the internal audit guys and did study. I surveyed a pile of people, et cetera, et cetera. And then I made 3 recommendations. One, get these guys some computers. There were 350 internal auditors and practically no computers. Second one, I said, you guys don't use any analytic methods, use it. And the third one was you have large systems that you don't understand. That's a big risk. You need to do something about that. About the computers was no problem. They had an affiliate at that time called Convergent Technology that manufactured PCs. So they had rapidly a PC in each person's desk. And then they asked me to teach them introductory PC lessons, which I had done at Columbia, so I happily did it there. About the analytic method, they had no idea what I was talking about. But about the risk in large systems was something that they had some empathy with. Something had happened, and I don't exactly know what had happened, but they were very sensitive to it. And they said, yeah, we are very interested on monitoring systems. What can you do? So I said, give me a small system and I will create a monitoring and assurance methodology. At that time, I was on really calling it continuous audit. And what they did is they gave me this thing called RCAM, Residential Billing System. And RCAM was the largest system they had. They had spent $1.2 billion developing it. $1 billion of the 80s is a lot of money today, correct? And they have spent $1.2 billion on it, and was key to one of their strategies. Remember, AT&T split up, and AT&T spinned out 7 subsidiaries: Bell South, SBC, etc., Verizon, that you all know, etc. That's what had happened. But what happened is that the telephone systems, the switches that connected the telephones to each other, stayed with the operating companies. So AT&T didn't have a way to talk to their clients. The way they were billing is passing the records of the billing to the operating company, who sent the long distance and local bill. So RCAM decided that we are going to re-communicate with my clients and bill them direct. And that was RCAM. It was a very large system with millions of clients. So they asked us to monitor that thing or to do something with that thing, and we did it. And the project, by the time I left the labs full time, there were like 30 people in my group. And I continue working with Bell Labs, but it wasn't my group anymore. But it was a very interesting project. And after about a couple of years, when they had something working, what happened is we saw a major problem. And so we interrupted billing, and we created the people in the billing organization got very upset with us. And they called us in, and so I went there with a couple of the people working for me. I chose the biggest ones because I was afraid that they will beat me up. And what happened is that I showed them the reports we had prepared and why we thought that the billing had to stop that day. And they looked at it, and they didn't look at the data I gave them. They said, how do you have a report like this? And they didn't have that kind of access, because what we are doing is we are picking up data out of the different pieces and creating our own reports on, it wasn't real time, but pretty close to real time. I'll explain that to you a little bit later. And so that was what they looked at. And when I explained the data we saw, they said they are going to investigate, and they did. And in one day, they knew what had happened. And the other thing that happened is when we stopped the billing, they got very angry and stopped our reports. So our reports were coming in from all over AT&T, and so they stopped sending it to us from the billing organization. So I called Bob Gardner up, and in about an hour, the reports were coming again, okay, because the CFO had called and told them to restart the report. But anyway, this was the fastest project I ever saw. By the end of the day, we had an agreement of a 5 MTS, members of technical staff project, to create a billing system monitoring like we had in auditing. And then my difficulty, that's $1 million. At that time was $200,000 per MTS. But it was complicated, the whole thing, because I had to go and talk to internal audit and explain to them why we are going to give our data to the operating company, to parts of the company. And they didn't want us to give the data to someone else. Okay, after I explained this is not a very big risk, is the other way, and we are going to create some analytics that are only yours. And at that time, I hadn't done very much of this, so I imagined, I said things like, continuous monitoring is different than continuous auditing, and continuous monitoring deals with small phenomena. Continuous auditing, particular, is really only material items in a longer period. So they finally agreed if I promised them to create reports that were only for them. And we did that. We did that, and we finished up. We started at RCAM. By the time I left, there were 4 or 5 other systems that we are monitoring, that we were asked to monitor. So it was very interesting because Bell Labs was a research institute. And so we developed the materials, we developed the system, and then we passed it over. Interestingly, Bell Labs had this tradition of post-mortems. And the post-mortem is you finish a research project that was applied, and they invite 2 or 3 scientists from other areas to review. And when in my post-mortem of CPAS, they really slammed me about the way I collected data. They liked the project a lot. And they said, why aren't you collecting data out of their databases? I am not stupid. I never did a project that I went directly into the databases of the company. Why? Because if you screw up, you stop their systems. Okay, and the stuff we do is very data intensive. So we always create the data warehouse, or we extract the data and analyze here at Rutgers. We never touch it directly. And so they didn't like that. They said, we called it the measurement technique as opposed to the database technique. But they didn't like it. But by the time I retired from AT&T, they probably had 30 projects collecting data that way. Because do you really want to risk interfering with the processes of a company? You don't. Now, I always say when we do all these projects, we are just now organizing a project with KPMG. And I always say the same thing. We develop a prototype. Hopefully it works. And if it works, you go and hire IBM or whoever and have created a bulletproof solution. We just developed the way of doing things. I always say that. I bet you that 3/4 of the projects we do just use our prototype forever. Because I went back, I retired maybe 10 years ago from AT&T. I don't remember how many years. And I went back a few years later, and they were still using CPAS. And what had happened, we did CPAS, continuous process auditing, and Prometheus, which was the measurement system for billing. Okay, basically parallel, same collection of data, etc. And they basically stopped CPAS and continue using Prometheus because gave them the data they wanted. So auditing and billing were using it. And I don't know if they're still using it. The only thing they changed is that we developed the system on a platform called News, and they re-platformed it into Windows. Same variable name, same design. I don't think they increased it a lot. I don't think they increased it at all, but they keep using it. So it's kind of interesting. I actually thinking of going back there. I'm sure they'll talk to me, going back there and having a look. But AT&T shrank. AT&T, there was a moment that they only had like 30,000 employees. And AT&T was 1.2 million When they split out, remained with like 350,000, 400,000. Came to a point they only had like 30,000 employees. And what happened with Bell Labs split up. Bell Labs, part of it went with operating companies, and then they created a thing called AT&T Labs, which is where I stayed, where I was. Okay. And this was, I always say this was a catastrophe for American science, because no other country had 20,000 people doing research. Lasers came from there, semiconductors, integrated chips, black hole, astronomy, those, etc. See, if US had still Bell Labs, they would probably be far ahead of everyone else in technology. I was reading this book about AI recently. You'll see some slides from it. And they started talking about names of guys that are prominent in AI, in other fields that I don't know. And there's people that I met there in the labs. And then now they are at Google, they are at Microsoft, everywhere. Very interesting type of thing. So what is this story? This is how we thought about it. Basically, a set of technologies picking up data and doing a thing that at that time I called it continuous audit, not continuous data audit. And what does that mean, continuous audit? Very simple model. The model is you have your computer systems and you measure a variable. And you compare the variable with the standard. And you also have a thing which I call variance standard. And if the difference between the two is larger than the variance standard, you issue an alert. Very, very simple idea. Data monitoring. And one of the first people that worked for me over there was someone I hired. Her name was Fern Halper. And interestingly enough, Fern's father was the ex-head of auditing at Coopers & Lybrand. And one day he called me in Manhattan. He knew me. I knew him for a while. And he said, my daughter needs a job. Can you hire her at Bell Labs? And she was studying, she had a PhD. She was studying the waves in the Gulf of Mexico. She was an oceanographer. And Bell Labs was full of those, was full of physicists, mathematicians, actually business graduates. I was one of the first they hired. But she knew about something called spectral analysis, which is looking at things in different frequencies. I said, she's perfect for Bell Labs. So I hired her, and we worked together until she left the area. And actually, I should give her a call, try to find her. But Fern did what we called at that time knowledge engineering. And what is knowledge engineering? There was AI, you're going to see in a second a couple of slides. AI goes through these phases. And in the 80s, this area called expert systems emerged. And this area basically said, in the beginning in AI, you were trying to kind of create formulas that link to other formulas that explain the phenomena. And expert systems was a different idea. You just talk to experts and replicate their rules in a system. And I called CPAS an expert system. So she went around the different parts of AT&T identifying what were the standards. I went a little bit with her, but I realized she was much better than me on doing that, and also firm, very decisive lady. She wanted something, she got it. It was great to work with her. We published 3 papers together. I was very fond of her. But she went around and found these standards. And basically what I learned with Expert System, because I did one also for buying stocks, I did several ones. What I found is that you go and talk with an expert in this process of knowledge engineering, they say, I don't have any rules, depends on the situation. After you work with them, give them examples, etc., you always come up with rules that they use. And we discover also what information they use. And they are not being coy. They just they don't have it in their head. They haven't formalized it. So I've done that about 3 or 4 times in large systems. And after a while, you kind of learn how to ask a question and how to deal with them. And so it was very, very interesting type of thing. This continuous auditing thing, the thing in about 2 years was working with many switches, was very, very interesting. And this was from 86 to 90. When I was already here at Rutgers, people from Siemens contacted me. Do you guys know Siemens? Siemens is a German company, maybe second largest or largest German company, and they produce all this electronics, etc. Very large company. And they actually were a very large company just in the US. At that time, they are about $20 billion in the US. And they said, you know, we have many, many copies of SAP. Does everyone know what SAP is? Is basically the most popular ERP, enterprise resource planning system. What are these? These are very large pieces of software with a database in the middle and all kinds of applications. And every large company has ERP, sometimes 10 of them. Okay, so what Siemens had is Siemens was a client of SAP, and so probably the 2 largest German companies communicating with, or maybe the car companies are bigger. And so they had like 150 versions of SAP in different countries, etc. And they said the problem is that we only can audit these things once every 2 years or every 18 months, and we need a way to do better. And so we developed the same idea that we had with continuous auditing. We called it continuous control monitoring, and basically looked at the SAP configuration and compared it with the standard. And if there was a change between the configuration and the standard, we issued an alert. And worked pretty well. Actually finished up that a couple of the software companies copied the model. We don't patent, we never patent our stuff. And at that time, we called that CCM, Continuous Control Monitoring. And we changed the name from continuous audit to continuous data audit, and said that continuous audit was these 2 modules cooperating. Okay, so that we redefined the name and etc. We published, I think at that time, AICPA monograph. We called it the Pink Book, because the first article on CPAS was published in 91. And this work started in 2003, maybe 10 years later. And at that time, we already had done a big project in Brazil with Itaú Bank. So we had done quite several things in in this area content. So this became continuous auditing in our terminology. And maybe about 10 years ago, I had a PhD student, Diane Moon, and he wanted to look at parameters of risk in auditing. And so we created this thing we call CRMA, Continuous Risk Monitoring Assessment. So we are talking now continuous auditing has 3 modules. What was CRMA? CRMA broke the risks of the company into 3 pieces. One piece, operating risk, straight out of the ERPs. And by the way, let me write this down because I see these faces when I mentioned SAP and when I mentioned ERPs, you all look to me. You guys, if you're going to be auditing, which most of you will, better know what the ERP is and what SAP is. SAP and Oracle, and maybe Microsoft, couple of Microsoft products are the ERPs that every company of certain size buys this integrated database with applications around it. So let me put it here. I was surprised that I know. So ERP, Enterprise Resource Planning System, SAP, among those. And what are they? Is a relational database and human resources, costs, inventory, etc., etc., etc. And there is one, financial reporting. And this is what you are going to be looking as auditor. So, and what is a relational database? Now, if I started, it's basically a database. In the old days, how did you store your data? You store your data in sequential basis. So you had the tape, magnetic tape, and you put your records like this, one after the other, for hierarchical database. Then that was very clumsy. They started this thing, RDB, relational database. And they created these tables with the data, and they link primary keys or keys one to the other. So you have hundreds of these corresponding to parts of the operation, and that's a relational database. And you have an operation here, you have a relational database in the middle, and this is the way most large corporate systems work. And when you are going to be auditing, you are going to be looking at things extracted from the ERPs. Now, back to this here. The CRMA, we divided this into operational risk, which you picked up out of the ERP, and then we had environmental risks, and those were things like gross national product, sectorial product, employment, etc., macroeconomic data mainly. And then we had these unusual risks, okay, which would be very large risks with very low probability to happen. Example, nuclear plant of Fukushima. Do you remember what happened to it? There was a tsunami, the waves came and covered the nuclear plant, and it went to pot. Okay, by the way, when they were building, we can call these the black swans. Not balance sheet, black swans. And it's a known thing in business. And so basically the 3 types of risk, operational risk, environmental risk, and these very infrequent but very high damage type of system. So when they built the nuclear plant of Fukushima, they thought about the problem of maybe a tsunami coming, and that was resolvable, put big walls around the nuclear plant. The nuclear plant was large, the walls would cost a lot of money, and they thought this is never going to happen. But it did happen. And so the way Moon divided it into these three ways, and that's CRMA. And it's very interesting how the world turns and things change and maybe don't change. We are at this moment looking very carefully at CRMA because I have been developing this thing I typically call it exogenous variables. And what is exogenous variables is measuring things with variables that are not out of the ERP. And I'm going to talk a little bit about this tomorrow, next week. We are now looking at doing CRMA with exogenous variables. And I have been arguing, I wrote an article arguing that companies should disclose their internal information and help the user, like you or you, to extract exogenous variables. And I mentioned this here before. I'm going to stop saying I mentioned before because I mentioned things in a sequence. I mentioned that these exogenous variables have all kinds of implications on what you do today. And what are these exogenous variables? We are going to have some slides on them. They are things like social media, weather, in the location, IoT. We have prediction of 25 billion IoT devices available by next year, et cetera, et cetera, et cetera. I always say IoT, internet was developed for people to talk to people. Now, the internet will be mainly a device for devices to talk to device. And the example I use is your car is going to talk with your refrigerator. Your refrigerator is going to talk with a little robot. We just bought this robot for our house in Long Island, and I assembled it, and I was very disappointed that it didn't talk to my refrigerator. It just cleans. Okay, but it's good. It doesn't hit anything. Kind of. I loved it. I wanted to play with it, and my wife said, "Let it be. It's mine," etc. But it was, I love the robot, by the way. You guys seen this? You might have one at home. iRobot. Yeah. They're really cool. But now, they detect walls. You can program there. We had one maybe 10 years ago. My daughter gave it to my wife. My wife is not very technical. And now I'm all excited because we have a new one. It's so heavy, and I'm trying to understand how it works. But back to this. So these were the three. Now the CRMA project of Diane Moon, basically what it did, and I give him a little bit of credit for my interest in ERPs. He looked at social media on a couple of events. And one event was a dog food company, and the food was killing dogs. And so that was a kind of risk of black swan type of risk that you could monitor. He looked at a couple of them. He published a paper and etc. But I started thinking, if you can look at social media, and then I had a student looking at weather to predict sales by store, I said, these external variables are very important. And now that there is a lot of these external variables, and they are important for it. So this is basically the schemata that we developed for continuous auditing over the years. This was in the mid-80s. This was in 2003. This was some like 2011, 12. And we did a pile of projects, one insurance company, the bank in Brazil, state in Brazil, Procter & Gamble. We did a pile of them. And just recently, I started realizing that we were constantly predicting. And it's very easy to say you should have thought before. It's called Monday morning quarterbacking. And oh yeah, I should have thrown the ball earlier or something like that. But even obvious things don't come obvious in research, in management too. But what we have been doing a lot is prediction. And then we had this project with an insurance company. And we did a thing called unsupervised machine learning, which I mentioned before. And I'm going to stop saying I mentioned before because all these things correlate here. But what we did is we looked in this insurance company at all the premiums they paid, all the debts that they paid. This was a life insurance, and when people die or certain health things happen, they pay money. Okay, and we looked at them, and we are trying to model this thing to predict how much money you're going to spend when all people die. Okay, so if you have a life insurance that's not a temporary life insurance, you have to predict. And so that's what we are trying to do. And it was very interesting because we use this thing called clustering. Clustering is unsupervised machine learning. And so we put things into groups. And what we found one category, a group, that has not been claimed from 7 to 10 years. They were a very small group of insurance policies that the person died. And so when I asked them, why is this group so unusual? Oh, they told, oh, this is not a big deal. This is because two siblings are fighting who gets the money. I just happened to ask this to Professor, you know him, he'll teach you, Professor Jay Solid, who is a lawyer. And Jay said, doesn't take 7 years here. Something is wrong. So we decided to look more at it. And we found one field in there that had a checking account number that the thing was paid to. You never used that number. We did. And turns out that 12 of those insurance were paid to the same account. So we figured out what was happening. Someone inside looked at life insurance, checked on death records, and if someone died and it wasn't claimed, he got someone outside, or maybe a relative, or maybe even himself, to claim it and pocketed the money. So we thought we had done a great job detecting this. We took it to the insurance company. They gave it to legal. And then I said, okay, tell me the story. No, we can't tell you. Legal won't tell us. I got very upset and I stopped working with that insurance company. But it was a prediction process. Has basically two major branches. One branch is supervised machine learning. You have an outcome, you have a lot of data in a matrix. You create formulas that link this to this. So you have going concern opinion. These 10 companies got it, this 1,000 didn't get it. You have all these numbers, you try to create a formula that predicts when people are going to get a going concern opinion. That's when you have an outcome. When you don't have an outcome, you use other technology, which is called unsupervised machine learning. And one of them is clustered. And there are tree-oriented ones, there are several. And this book I was reading yesterday said, supervised machine learning, we are doing very well. Unsupervised machine learning, not so well. So there we were working, and we have several projects we do prescription. predictions. We have these things that we call suspicion functions. And by certain things, like a transaction is done in a weekend, a transaction is done at lunchtime, the buyer has the same name, the payee on this thing has the same name as one of your employees. You have this whole set of risk type of variables, you create a risk score. And by having a risk score is a prediction of the risk of this particular transaction. We just had a paper published with one of our ex-students. She's at the College of New Jersey. And what she did, she got data from China. Very interesting data. In China, you have to register material audit adjustments. Here, you don't have to register it. You have to do the adjustment, meaning you audit a company, you see a discrepancy. You don't gong the company. You first ask the company to make an adjustment. If they don't do adjustment, you probably just withdraw from the engagement. Okay, but that number never appears anywhere. In China, you are required to declare it to the government. So we looked at those adjustments and created a machine learning methodology to predict adjustments. So that meant, and created a number called the suspicion function that adds those parameters into, and if the suspicion function is 90%, it's very dangerous. If the suspicion function is 20%, not particularly dangerous. So that's what the suspicion function is. And then it became obvious that we could do one other thing, which is if you find a particular transaction to be very dangerous, you intervene before it's a... So I was describing that insurance situation. If you would find that a particular insurance claim is 8 years old, goes to that account that we thought was danger, you wouldn't execute it and follow it up. And so we realized that in several of our projects, several projects with the bank, et cetera, we are doing these predictions, but it was very audity after the fact. And then we realized that we actually could intervene and not let the thing happen. And so that's our current big discussion, and we are thinking about finding a project. And we are just at this moment negotiating a project where they are going to do something that we had never managed to get. If they are going to give us access to the relational database, and we can extract whatever we want, so we are going to create these suspicion functions and try to do continuous intervention. Why are we getting this? Companies don't like to give it to you because they don't want anyone to know who their suppliers are, who their clients are. It's risky for them because they don't want competition. Now, these guys that hopefully are going to open the databases for us happen to be counties. And some of them have a charter that requires them to publish their data publicly. So I don't think the charter say publish it immediately, but they have. So Kings County has said that they'll open the database. So there are 3 counties now that agreed to open the database. Let's see what it works. And okay, so a couple more things about continuous auditing. I said that continuous auditing basically has 5 parameters. Metrics, which are the measurement of the parameters, in this case at AT&T, of whatever you're measuring. The standards, the thing to compare against. And there are 2 types of standards, the standard of the activity and then the acceptable variance. okay? And then rules, which we call the analytics. And finally, the one that I was talking before is how you access the data. And what the people at Bell Labs wanted is for us to direct access to the database. And what we actually did, we extracted the data and analyzed it separately because we didn't want direct interference. So, showing this on a graph, you have the ERP system, okay? You measure it, you compare it with the standard, you compare it to the standard of variance, and by the way, variance could be positive and negative. And then you issue an alert. So this was, for 2 decades, our rules. But now the world is changing. And there is other information that you can use. So I told you we have a project we are talking with KPMG about. And this is actually variations on the theme of things that we have done before. But if you have a public county or whatever, what do you worry in fraud and in corruption? Give me a couple of things to worry about. Okay, I'll give you one. I'm worried that you have a girlfriend, she owns a company, you work internally, so you buy from her company and pay twice as much that you should. So how do you detect that? We had a project that we worked with the Mayor's Office of Rio de Janeiro, Brazil, which is about 9 million inhabitants. And we looked at medication. They have 6 hospitals. And we looked at medication. It was category 60, 61, and 62. So how did you find out that the medication was overpriced? We used exogenous variables. Have you ever heard of the expression screen scraping? Screen scraping is you open a screen and you pick up data from the screen with a computer. So we went into the Brazilian CVS, meaning a seller of drugs, put in the name of the medication, and scraped out the price that they were charged. And then we compared that value with the value that the government was paying. Now, the government had 3 ways in these hospitals to buy medication. One way, central procurement. They bought Band-Aids, I'm just inventing it, for 6 hospitals. So what they could do is discount it very deeply, correct? Large volumes, you charge less. Okay. The other way that they bought medication is in groups, like this, and that, by the hospital itself. And then the emergency buy. I need antibiotic, I don't have, you go to the pharmacy, bring it in. So you would expect that the last one is the more expensive, correct? Because you buy one, not in quantity, or etc. And actually, we found out a very interesting thing there. First, the centralized buying wasn't the cheapest, and they were buying drugs in one place for twice the price of the other place, one by one. So this not necessarily means fraud, maybe availability, etc., etc. But what was very interesting is that we now had an external variable which is capturing the price on the screen and comparing with what you're spending. At that time, never occurred to us that we could do interference. Every time you buy, you check against CVS, and if the price is lower at CVS, you stop the transaction and buy from CVS. You know, it's very easy to Monday morning quarterback. We should have thought of that. Yes, we should have thought of that, but we didn't. Okay, but we are starting to discover that there are a lot of variables. It's not only in bribery, it's not only in inefficiencies. There are many types of variables that serve. You're talking about internal controls. There are ways to verify if the control is working or not using exogenous variable. So this was basically, this is where we are at this moment with this continuous auditing stuff. And the idea is that we interrupt a transaction that might be a fallacious transaction. So these are the kind of, so I told you the story of our projects in continuous auditing, the CARLAB, and before the CARLAB when I was at labs. And as you notice, things developed over time. Now I want to ask you a question that I have been pondering, and I don't really know what we should do. Very simple question. If you apply these exogenous verifications or filter with risk, is this an audit or more like a control activity? So maybe my continuous auditing is not continuous auditing anymore. That's my dilemma here. Other interesting question about this is what we are working now, thinking about now. The other question is internal audit the same thing as external audit? So that's the dilemma. You are describing the dilemma. I don't know what's going to come out of this. Let's suppose that we can monitor every set of processes really closely. That's really kind of secondary control. And let's suppose that you can intervene on bad things happening. That's also a secondary control. Is that an audit? Does that have audit implications? Of course, big audit implications, internal and external. So I don't know what's going to come out of this, but it's interesting to think about what we are